a Bronsted-Lowry acid is going to be anything that's a hydrogen ion donor. We also say a proton donor instead of hydrogen ion because an H+ ion is essentially a proton. After an acid donates a hydrogen, what you have left over, the result of that transfer, is a conjugate base. And then together they form a conjugate acid-base pair. A Bronsted-Lowry base is going to be a substance that is a hydrogen ion acceptor. And so we also call that a proton acceptor. So the hydrogen donates, the base accepts or receives. After a base accepts a hydrogen, the result of it is a conjugate acid, which together they form conjugate acid-base pairs. So we're going to identify the conjugate acid-base pairs in several examples. And remember, all conjugate acid-base pairs only differ by one hydrogen. So the first thing we'll do is we'll notice we have our reactants on the left, our products on the right. And what I want to find is my conjugate acid-base pairs. They should only differ by one hydrogen. So if you'll notice, HCl and Cl- are conjugates of each other because they practically look identical, but they only differ by the fact that this has the hydrogen, but this does not. So these two are a conjugate acid-base pair. Now, who's the acid? Who's the base? Well, the one with more hydrogens is able to donate a hydrogen. So this is going to be my acid, which is the hydrogen donor. And this is going to be my base, which is the hydrogen acceptor. So if this donates a hydrogen, it's going to lose a hydrogen and it's going to become this. If this accepts a hydrogen, it's going to gain a hydrogen and then become this. So that's how they are conjugates of each other. All right, the other pair are going to be, hopefully it's obvious, the H2O and the H3O. They only differ by one hydrogen, so they are conjugate acid-base pairs. Which one's the acid, which one's the base? Since this has more hydrogens, it's got more to donate, so it's going to be the acid, the hydrogen donor. And then because this one has less hydrogens than this, it's going to be the acceptor. So that makes it the base, the hydrogen acceptor. And so the way we would answer this is a couple of ways. You might be asked to label the acids and bases, and you'd say from left to right we have acid, base, acid, base. Or you might be asked to identify the conjugate pairs, in which case this is a conjugate pair and this is a conjugate pair. Or you might be asked, if you have the acid HCl, what is the conjugate base? And you would have to know, well, if it's an acid, it's going to donate a hydrogen, and then after it donates, what it becomes is, in fact, going to be the base. So those are about 3 different ways you might be asked to answer questions about something like this. All right, let's look at number 2. So number 2, identify your acids and your bases. So since these are conjugates of each other, right, and then these are conjugates of each other. Now that I know my conjugate pairs, which ones are the acids, which ones are the bases, between these two, this has more hydrogens, so it's the acid and this is the base. And then between these two, this has more hydrogens, so it's the acid and this is the base. But this should check out because if it's an acid, it's a hydrogen donor, and if it's a base, it's a hydrogen acceptor. If we keep in mind our definition that this, if it donates one hydrogen, it's going to change into OH-. If this donates a hydrogen, it's going to lose one of these 4 and drop it to 3, and it's going to become NH3. Also, notice we're losing a positive, so that's why this was positive and then it becomes neutral. And then same here, we're losing a positive when we donate a hydrogen, that's why this results in a negative charge.